Hello, everyone. My name is Linden, and I will be presenting problem 28 from the sprint round. This problem reads, in the year 1989, a renowned psychic predicted that the levitating hoverboard would be widely available by the year 2015. However, the year that it will actually come out is both a perfect square and a perfect square number of years after 2015. What is the sum of the square roots of all possible years in which the levitating hoverboard can come out? So why don't we go ahead and try to visualize a timeline. And we're going to say that this over here is year 2015. And this over here is the year that the hoverboard is going to come out. We're going to call it year A. And we know that A is a perfect squared. So we can actually write this as, we're going to say n squared. What we also know is that this distance, the number of years after 2015, is also perfect square, so we're going to call it k squared. And because k squared is the distance between 2015 and n squared, we can write n squared minus k squared is equal to 2015. Now, what do we want to find? We want to find the sum of the square roots of all possible years in which levitating hoverboard can come out. That means we want to find the sum of all of the possible n's, all values that n could be. And we want to keep in mind that n and k both have to be integers. They both have to be positive integers. So let's try to figure out how we can figure out what n could be. Well, if you know difference of squares, you know that n squared minus k squared is going to be equal to n plus k times n minus k. N minus k. This is going to be equal to 2015 because both n and k are integers. We can see that both of these numbers must be factors of 2015 and they must multiply to 2015. So what can we do? We want to write down all possible factor pairs of 2015, noting that n plus k must be bigger than n minus k. Now, to find the prime factorization of 2015, we first notice that it's divisible by 5. We can divide that by 5. And we get this is equal to 5 times 403. And you might say, wait a minute, isn't 403 prime? The answer is no, because if you look closer, 403 is equal to 13 times 31. So all possible factor pairs n plus k and n minus k that multiply to 2015 must have 5 going to one of the factors, 13 going to one of them, and 31 going to one of them. And we see that there are 4 possible ways to write a factor pair. The factor pair 2015 and 1, the factor pair 403 and 5. Then we have the factor pair 155 and 13, and the factor pair 65 and 31. And you see that in all of these, you have n plus k equals 2015 and n minus k equals 1, or n plus k equals 403, n minus k equals 5, or so on and so forth. And in general, if you have n plus k is equal to something, we're going to call that x, and n minus k equals y. To figure out what n is, we need to solve this system of equations, and we can do that by elimination. So if we sum up the left-hand sides and the right-hand sides of these two equations, we get n plus k plus n minus k. The k's cancel out. You're left with 2n is equal to x plus y. So n is equal to x plus y divided by 2. In the case of each of these factor pairs, you see that x and y can be 2015 and 1, 403 and 5, etc., etc. So to figure out what n is, you take the average of each of these pairs, which is, for the first one, 2015 and 1, the average is 1008. Side note, this means that the hoverboard would come out in year 1,016,064. Similarly, another possible value of n is the average of 403 and 5. If you add them up, you get 408 divided by 2, you get 204. If you find the average of 155 and 13, you get 84. And if you average 65 and 31, you are going to get 48. And now these are all of our possible values of n, and we want to find the sum of these, so we just add them up. You get 1008 plus 204 plus 84 plus 48 is equal to 1344.
And this is our final answer.
This is Tim. Hope you're enjoying our videos. If so, you know what to do. Like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.